offices opened out there yet? Have all official activities begun?
Yes, sir. All kind of office has been started, but the university has been opened, but the university school college is not opened yet. Official
Okay, got it.
activity has been opened, but not the academic activity didn't open yet.
Okay, okay. Got it. Thank you.
Hello, am I audible?
Yes, good evening, Amit.
Yeah, sir.
Okay. Hello, Mona Lisa. Good evening. Now, Dr. Das, you can start
Good
sharing.
evening, sir.
Yes, good evening, Mona Lisa.
Okay. All right. Very good evening to all of you. This is my kind request that if you don't want to talk at the present moment, it is better you can just keep your mic in mute mode. That would not interfere with the class. So thank you. So I would just share my screen. And so I hope you had gone through whatever I told regarding the binomial logistic regression in the last class, right? So I hope there is no any kind of doubt from your side, because if there is any doubt, major doubt, then we will not be able to proceed with the multinomial logistic regression, because things are linked. So hoping that nothing is wrong.
Just summarize within 5 minutes what I understood from there that in the binomial regression, it's multiple cells.
Okay. I must inform that Amit, something is up with your mic. Maybe your audio is not basically coming clear. I have heard what you have got to say, but next time I believe you can just look into the jack. Maybe it is loose or something. Anyways, so that I can hear clearly next time. Okay. So please look into it. Okay. So I have brought the slide because thank you, sir, for giving me the time. This time I had enough time to prepare the slides and all. So thank you. So anyways, so like I said in the last class that binomial logit regression is basically when the DV is nominal in nature, and secondly the IVs can be, all of the IVs can be metric, or all of the IVs can be nominal, or they can be mixed. The example that I provided you in the last class, it had mixed results. I mean, mixed variables were there. One was nominal, the others were basically metric data. So here also the same thing applies. The only thing that varies from the previous one, binomial one, is that in case of multinomial data, you will find that the DV, which is obviously nominal here, also has more than two levels. It can be three, it can be four. So if it is more than two levels going on, then you can rely on the multinomial logit regression, because if you try to run a DV in the logit regression module, in case of SPSS or anywhere in the software, binomial logit regression, if you choose, it will not give you the option to add the third variable at all. So no point of trying also. It will allow only two. The third one will be left off. So surely you have to move on to the multinomial logit regression. So basically the theoretical part I'll be mentioning a little bit to you. What is it all about? Okay. So I have already introduced to you what is it, why do you use it in case of research. So I have given you the definition of regression, and also I'm not wasting any more of the time. So like I said, the thing is being repeated over here, that the nominal dependent variable must have three or more. If it is two, you can go for the binomial one. The IVs can be metric, the IVs can be nominal, or can be a mixed approach of the both. Okay. So it is basically an extension of the binary logit regression, as you know. Okay, so where binary logistic regression had two, this had three. So basically, it is an updated module. Basically, it is an updated model of what we used to do in the binary logistic regression. And moving ahead, so we would rely on the log odds. I mean, the odds ratio we used to find out, the logarithm of the odds, and from that we basically came to the EXPB, which was the odds ratio, and we interpreted the module likewise. So here one unique thing, like I told you yesterday, the p-value approach, other than the p-value approach, the EXPB or the odds ratio approach was used here. So basically we will find out the ratio, the odds ratio of what are basically the opportunities, the risk of the IVs falling into a certain DV type, certain DV level. So that we talked about in the last class. More information I'll be giving you in the upcoming slides. So the odds and the log odds, regarding this I have talked a little bit. The formulas and all are given over here. I was not using the slide last day, so I could not show you the different equations of the log. So I had talked about what are the odds ratio. So the probability of an event occurring related to the probability of an event not occurring. Okay. So why do we take, in place of the probability approach, only the p-value approach? Why do we take in the logit model the p-value as well as the exp value? That question I had answered you in the last class, but still in a organized way I'm showing you. I've been able to show you the text over here in this slide. You can check the marker, the blue colored, the green colored and the red colored text. You please note that is probability will range from 0 to 1. Odds range from 0 to infinity. However, the log odds that I have taken over here will use minus infinity to plus infinity. Actually, we can use both the odds and the log odds. All right. So the log odd approach is important when you have a nominal variable going on into the model. Like I said, in case of a nominal variables introduction, the AIC, BIC, this kind of measures are important. So here also, because you are using a nominal variable model, it will be treated a little bit different as you do in case of metric variable model, like in case of the simple linear regression, the multiple linear regression. So here also, because of a nominal variable approach, the extra added thing that I have also shown you in the last class, we are using the odds ratio approach over here. And in the same way, like we interpreted that model in the upcoming section, you will see when I'll be doing in the SPSS, we are using the odds ratio to interpret our findings. Moving ahead, so multiple logistic model. This is the same thing that I have basically told you how the arrangement is going on. Okay, so likewise, once more, I will just show you that basically this data will rely on, first of all, a y variable, so which is basically nominal with more than 2 levels. Okay, so y with nominal variables with more than 2 levels, it has been done. Then you will be having a y-intercept plus the b1x1 plus the b2x2 plus up to dot dot dot. It will be go up to bn xn. So the x, I'll show you with red. The x, this x2, this xn, whatever be it, they may be, nominal with any level. Okay, then it may be also metric, or it can be mixed, n or m, mixed approach it may be there. Okay, so like this the model will be designed, and let us now proceed forward. So basically some equations and all are given over here. You can check some important equations are there. We are not wasting any more time discussing the equation, because we are doing it hands-on the SPSS, not hands-on manually the sum part. So you can check the theoretical part will obviously bring in the equations, and that is why it has taken a place in the slide. We will just move along. So I just proceed to the assumption checking portion after the equations I've shown you. So first of all, PV should be measured in the nominal level. I'm repeating it multiple times. It is the same thing that I'm telling. The DV should be nominal level. And also the level should be more than 2. Then again, the assumption to 1 or more IVs that are basically continuous, ordinal, or nominal. Like I basically told you, any of the types of the variable are allowed. Okay, the 4 levels of measurement, whatever be it, nominal, ordinal, equal interval, ratio, any kind of variables are allowed over here in the IVs. Okay, and also it can be a simple multinomial logit model. It can be a multiple multinomial logit model, depending on whether you have only one IV going on versus whether you have multiple IVs going on, like I showed you in the last class again, as you remember. So assumption 3, you have independence of observation and the dependent variable should have mutually exclusive and exhaustive type. So categories should be mutually exclusive and exhaustive. Again, I have told you this one. It should be independent of observations, and like I told you, it will yield you better result. It will suit the model better, and whatever results you get, if it is independent, that will be more reliable. Otherwise, if you have other codes like which is playing a major role over here, upon which the present codes are basically dependent upon, and you are not bringing them, you are not introducing them in the model, that means a lot of your pseudo R square will remain unexplained, and that will prove that you have a less fitting model over here. Okay, so let us now proceed. There will be no autocollinearity, multicollinearity, these things will not be there. Obviously, autocollinearity, multicollinearity, these things should be checked. If it is multicollinear, then obviously the important understanding from it is that the variables are basically having a relationship with one another, strong relationship. And the larger the relationship is, the stronger the relationship is, the more basically the more amount of questions will be raised as to why are you including so many variables in the first place. There should have been only one. Go for a simple uh, multinomial logit model, and don't go for multiple multinomial logit model which has multiple IVs, because it has no point. They're strongly correlated. Like I told you, that the factors in any model, in an ACM model, should not be strongly correlated with one another. Otherwise, the construct validity will be affected, obviously. Discriminant validity particularly will be affected if they are strongly correlating, if the factors are correlating. So the same thing applies over here. Then assumption 5 then says it has a linear relationship with any continuous independent variables and the logit transformation of the dependent variable. It has to be a linear relationship which needs to go on, right? It may or may not be this continuous IV, even if it is nominal IV, then there should be a linear relationship between them. Then the linear relationship will be pseudo, because how can you draw linear relationship between two nominal variables, right? So pseudo models, pseudo linear relationships has to be checked for like that. And if the IV is a metric variable, then to no issue. Assumption 6, there should be no outliers, high leverage values, or highly influential points. Again, it is very important to note, like I told you in the last class also, any regression model, be it the simple or multiple linear regression or the logit model that we are doing right now, there must not be outliers. The presence of outliers basically makes it a deviated, distorted model. You can check the R square, the pseudo R square, in this case, the Nagelkerk's R square. They will be gravely affected if you are having outliers. So always remember to check whether you are having a large number of outliers, especially when it is a case of metric variables. Suppose one of the variables in your IV is basically continuous or metric. So don't forget to check whether they are having any outliers or not. Okay. The super stringent requirement of the metric variable of being normal data, that may not be followed. It can be a little bit skewed also, a little bit, I mean. However, there should not be any significant outliers going on. If there are a lot of significant outliers going on in the model, then the skewness is too far, and the model will be hence deviated, and the problem will be reflected in the Nagelkerk R square if you check it. Okay. Then I'm going on to the model fitting criteria. Obviously, this chi-square and all I will check, like I basically told you, the HL test, the HL chi-square, the whether the model fits or not, those kind of matrices will be given to you by the HL chi-square. And then obviously the pseudo R square, the Nagelkerk R square that I'm telling to you, which I have also mentioned in the last class, is very important to note. Check whether the pseudo R square is low enough. It can be average 0.5 and all. is still okay. However, values below 0.2 or below 0.25 means a lot of variances are there which are unexplained in the model. So the model is not a good one. If it shows significant values also, then a low R square means that the external validity, the generalizability of this model and whatever theoretical implications you draw out of it after interpretation, that will be weak one, and you cannot generalize it upon the entire population out there. So it has some information regarding what R square is. As you know, it varies from 0 to 1. Okay, it is always positive because it is R square. So the higher the value, the more it approaches 1, the better it will be. So now we will basically proceed. And also, if you want a stepwise regression, it is also basically possible.
Yeah, Dr. Dash, can you make
Yes.
it full screen?
It is not full screen right now, sir?
No.
Okay, okay, okay.
Yeah, now it is full screen.
Okay. So analysis and interpretation from this. Actually, no point of doing full screen now because I'll be shifting to the SPSS. Sorry. So I'd just be from this portion, analysis and interpretation. I'd like to take you to the SPSS data. Let us speak about the data a little bit. Okay. I'm doing this full screen one more time. Suppose we will be having the different kind of programs. Okay. So the academic, the vocational, and the general program. Okay. These are the different kind of program. Okay. This is basically the HOS order data. The name of the data is, I think, HOS order. So from this data, it is available in R also. You have to download it from a link. So from this data, we have got some, educational kind of a data. And so general program, vocational program, and academic program is there. So from there, I will basically take the DV, that is writing, the writing score. Suppose the written examination has been taken place and the scores on the written examination is here serving as the DV. And another DV, this one will be, as you can understand, the writing score is obviously a metric variable, right? So the socioeconomic variable, as you can see by the name, it will be, the low class, the middle class, the upper class. So I'll be taking this as another DV, which is nominal in nature. Okay. So I hope you can now understand how the data basically stands. So the general program, vocational program, academic program, and then the IVs will be the writing score, the socioeconomic status. Socioeconomic status is low, middle, upper class. Okay. And writing score is basically the metric score. So now let us take you there. I'll move to the SPSS. Here you can see the read, write, ACS, and this program one is there. If I shift the view, you can see vocational, general, and academic. These are the three levels. Okay, this is my DV, the nominal DV. The ACS, the low, mid, high, this is there, and we will take the write data only, not the read one. It is present. I'll also show you by inputting the read also. But let us include these two variables for the ACS one, that is the first DV, and the write as the second, sorry, ACS one as the first IV and write as a second IV. So what to do over here? You have to go to analyze, regression, same place where you left, multinomial logistic regression, you have to click on. Okay. So I hope you will write down the trail. Mr. Pandey is not here. You were there in the last class, right, sir?
Yeah, Shubham is not here today.
Okay. Anyways, okay. So please write down the trail, analyze, then regression, then multinomial logistic. You have to click it over here. So the option will basically be here in front of you. So read, write, ACS, and this program, you have to move this program one onto the DV because it is vocational, general, and all, right? Reference type, which one you will take as the reference one? You can take the first category as the you can take the last one also, no issues with it. You can click on the last one and you can click on OK. So you see the last one or the first one does not matter. Sometimes you want to basically analyze something with respect to something. If you have such any kind of mental setup like that, you can choose either the first or the last one. Or here, while you put the reference type, you can also use the literature review. If you have any literature background stating that the last one should be, put as a reference category, then it's okay, move forward. Otherwise, it is free for you to choose, like I told in the last class also. So here, the factor will be what? The ACS one, because it is a nominal variable. According to the factor, I will break it down. So the, you know, this high, low, and middle ACS will play as a factor variable over here. And then you will put on right over here. So the right is our main IV, which is basically the metric IV, and I have basically put it over here. Just click on statistics. Nothing to change. Basically, wait. This is how it will be presented to you. Okay. This is how it will be presented to you. Make sure you have these things clicked. Okay. Pseudo R square, model fit information, and a step summary. This will be the basic setup by default, and make sure you have the clicks over here. Please note it down. All right. The other things are not required. I'm not including the other stuff over here right now. Okay? May I then proceed? Okay. You can just click on OK. Criteria and all, it is not required. Options also not required as of now. Save and bootstrap also not required as of now. So the main thing is make sure you have the ticks over here. Pseudo R square, step summary, model fitting information, estimate, likelihood ratio test, asymptotic correlation. By default, it will not be given. I have given a click, though it is not very important. It is also optional. You can or you may not, you may or may not put a tick on asymptotic correlation. Other things will remain as it is. Confidence interval, don't touch. It is according to the APA rule. You need to show the 95% CI for any regression analysis out there. So you can just click on OK. So then nothing else, just click on OK over here. The answer will be brought in front of your eyes. So this is a summary of the results. As you can see, academic, general, vocation, the N number is given. ACS is high, low, and mid. Okay, more or less all of the types have been represented very well. So the N size is valid and is 200 in number, which is quite a lot of number, quite a lot of sample is available. The model fitting information that also I have here. So the final one, you have to check the final one. We don't see the intercept, right? So you check the final one, model fitting criteria. Not only this one, this, actually the model fitting criteria, this can serve as the AIC. This final one, this is equivalent to AIC also. So the likelihood ratio test, this is like the HL test. Chi-square is showing 48.23, and unlike the last class, here we have a good fitting model. Look at the p-value, it has come to be significant enough. So the model is fitting, we can proceed with the model. Okay. So the first diagnostic criteria has been checked. The next one is R square. You just have to accept whatever has been shown over here. Nasal Kirk is 0.246, which is not very, very good. If 0.2 is the minimum, limit of accepting any model, it just falls a little bit above the limit of 0.2. It is 0.246 or 0.25. So it is not doing very good, but still we can basically proceed. So what does this mean? There are many other variables which required to be included into the model, which the researcher could not include, and that is why the R square has basically come to be a little bit low. The Nagel Kirk's R square, even here you can see this is a normally generated data. This data is a normal kind of a standardized data used by R and all, but still it shows a pseudo R square of this. Basically, it happens when you are using a logistic regression model, because of the nominal variables out there. Often there can be inflation in the R square. Often there can be a deflation in the R square. It is always better if you have the opportunity to do it. Mark my words when I say, if you have the chance of doing the simple linear regression or the multiple linear regression using all of the metric variables, go for that one. That is always recommended. Whenever you come into the nominal variable zone, you are losing a lot of information, that I must tell you, because the non-parametric or the nominal approach is not always recommended. But why do we do it? Because we have no other way. How can I change gender into the metric variable? So if you have the opportunity to use the metric variable instead of nominal variable, always I would say go for the metric variable, because the all parametric or the all metric model would give you much power. Much of the statistical power will be there, and your interpretation and your generalization will also be strong enough. So anyways, I'm not going into what error might have caused the low nasal Kerr R square in a standardized data. I will move forward. So if you want to check, this is equivalent to the ANOVA one. Okay, this is very much equivalent to ANOVA kind of a data. Okay, so as you remember, in the ANOVA, we needed to check whether the model is doing a good fit or not. Here also, suppose we have the ANOVA sort of like for the two variables, for the two IVs, whether they are working well or not. So it is equivalent to that only. So I can see this chi-square and the p-values. So the right one, the right or the metric variable is showing you a significance of 0.000. The ACS being a nominal variable slows slightly higher p-value. However, it is again significant at 0.05 level because it is approximately 0.027. So we can just basically proceed. Okay. So both of the IVs are working well in this model and we can basically proceed. So now we can see this parameter estimates. This is the main interpretation table. So here you can see that the academic is being shown and the general is being shown. Out of the three types, the vocation, we took it as a reference category. Remember the last one was taken as a reference one. So academic, general, vocation, it was like this. You can check. Academic, general, vocation. I put the last one here as a reference category. So the A will be checked on the lights of vocation. The G will also be checked on the lights of vocation because V was kept as a reference variable. So that is why the V is not here, because I am basically telling the academic and the general with respect to the V. So how can it be here? That is why the academic and general only here is, and the vocation is not given because it is in the reference category. So like I told you in the last class, we will ignore the intercept one. First, let us interpret the academic one. So in case of the right, which is the metric metric IV, you can see the p-value is doing good. ACS1 is basically doing good. ACS2 is not doing good. Again, ACS3 will be a reference one. That is why for the AC3, ACS equals to 3, the value is not given over here because we will basically tally ACS1 with ACS3. We will tally ACS2 with ACS3. So the ACS3 value, it is a nominal type. It will not be there. One will be missing, right? So the ACS3 is kept missing the higher one. So now let us interpret. First of all, let us go for the academic one. Then we'll go for the general one. Okay. So the academic one says that right is p-value 0.000. So we will interpret it. How do we interpret it? Check the odds ratio 1.12. So with an increase in right, why did I say with an increase in right? Because it is a metric variable. With an increase in right, it is 1.12% more likely that it will lie in the academic group as compared to the vocational group. higher writing score is 1.12 times more likely to be found in the academic program as compared to the vocational program. Again, I am saying, listen, imagine what we are trying to find out. Right means the written exam and the score. Our objective is to find out in which program the written score will be higher, right? So the written score is likely to be 1.12% or 1 to 1.12 times more likely to be higher on the academic group as compared to the vocational group. Done. Then you go for ACS. So the ACS also, with respect to the ACS 3, let us go for ACS 1 first. Okay. So what is 1, 2, 3? You can see high, low, mid. I hope you can see in the screen. ACS 1 was high, 2 is low, and 3 is mid. So I will firstly check high with respect to mid, then low with respect to mid. Now you check. So ACS high is 3.575 times more likely than ACS 3 to be in the academic group. Understood? So high ACS people is 3.575 times more likely than the low ACS group to be found in the academic program. I mean, the students who are sitting, suppose there is an academic program classroom. Okay. In this, the students are 3.575 times more likely to be from the high economic background than to be in the low economic background. At the same time, you check ACS 2. So again, like that, you can interpret that it is 1.1338. I mean, the middle class. The middle class is 1.338 times more likely than the low economic group to be found in the academic classroom. Okay. Now, when this is done, go towards the general side. This is another program. So this general program shows, first of all, okay, I must say that the ACS2 I have interpreted, however, the p-value is not significant. Note it. You can write down in the interpretation, but you must note that whatever be the result, it should not be relied much because the p-value is doing insignificant. That I must add. Okay. Here also, I can see that only one, that is the right, is doing good. However, the ACS1 and ACS2, none of the socio-economic status is found to be significantly different from the ACS3, that is the low side, which means because the all of the ACs, AC1 and AC2 is not significant, you know what that means? In this classroom, general program classroom that it is here, socio-economic status is not a big matter. Differences are not significant enough. They are more or less equally distributed. No important discrepancy you will see among the number of the low, the middle, or the high group. Okay. So what happens here is that you can basically focus on the right here only one, because that is the only significant P, 0.017. So right one is more likely to be falling on the general group. Why? Because the B is basically positive, as you can see. The B value is basically positive. So right will be falling in the general group, and it is 1.057 times more likely to fall in this group than to be falling on the vocation group. Okay. ACS 1 and 2, I am not interpreting because they are not significant. If they were significant, also for your practice, again, I am saying ACS 1 is 1.905 times more likely than ACS 3 to be falling on the general program. And again, ACS 2, if it was significant, I would mention that the ACS or the middle class is 2.281 times more likely to be falling on the general group. Okay. More likely than what? The ACS 3 type, the high socio-economic status type. So like this, you are interpreting it. You can note everything, every single information here that is given is important for your APA APA presentation, your APA writing, APA style writing. Okay. The asymptotic correlation matrix is given over here. You can look for it, okay, because it is a nominal correlation. It will help you understand the different correlation across the two different groups, the academic and the general, with respect to the reference one, that is vocation. So if you want, you can use this non-parametric correlation matrix and add it on your paper. The next thing that I will show you is here. Okay. Suppose I will basically tally it up with what are the differences between the ANOVA and the beta and the R square that you used to get in the simple regression analysis and what you are getting here in the logit model, be it binomial or be it multinomial. I will draw the similarities and I will show you what was the picture there in the multiple or the simple linear regression versus what same thing we are seeing over here. Please mute yourself. If you want to ask anything, then please say. Okay. So suppose I am basically, finding out the regression analysis, the linear regression analysis. This is just a dummy run. This is just a trial run to show you what is happening over there. So I will use the nominal variables also. Please don't mind that. This is just for showing you. So the read value, suppose my dependent variable is read and independent will be write and the ACS. Okay. These two I have just taken. Confidence interval. Descriptives I don't require. The DW statistics I will pick. Options, nothing else much. R square change I don't require, nothing else. So here now you check what is happening here. Okay. So there in the multiple linear regression, and this is the multinomial logit regression. Check what was R square over here, that is Naegel-Kirk over here. Understood? Understood, Amit? Farah ma'am? Basically helping you understand to basically discriminate between the two models, the metric model and the nominal model. Okay. Next one. What was ANOVA in SLR? That is something where we are drawing inference from this model fit, this and this. This and here. This is M log it. Now you check. So in simple, I'm sorry, in multiple linear regression, what was ANOVA and the ANOVA's p-value? Here you have this one chi-square and the chi-square's p-value. This is for the entire model. Additionally, for each of the variables, each of the IVs, you have their chi-squares as well and their fitness p-values as well. Is it clear? So like this, I'm showing you what used to happen there, and the same thing, just the names will get changed, but the functional availability, the way of interpreting, the requirement checking, assumption checking will be the same thing. Just the names change and the ways change. Okay. Also, you check this one, and here it is. Here, this one is multiple linear regression. This one is multiple logit. Okay. So now you check. This was the slope p. Okay. This was the p value. This was the beta, standardized beta. This is so same. This thing will remain same. 95% CI, 95% CI here also. However, here this is B. So basically the world will work as the beta over here. And this is the P. And this one is extra. This additional one, this works as the odds ratio. Okay. I'm showing you in this the multiple linear regression module versus the multiple logit module. Please everybody check and ask me if there is any kind of discrepancy. Note that since it is a parametric test was falling on this parametric domain, the T was used. Here there is no T. Okay, only the DF has been mentioned. Okay, so also the AC was given over here. Here also the AC stays. This one is the same. So I hope now you can understand how it works. So now one last thing I will show you is the graph. I have basically shown you how to interpret this thing. Now another is the probability curve of this one. Okay, how to check the probability estimates of how across the academic, general, and the vocation group is working, and how it is varying across the different factors. See, in the y-axis we have the probability value. In the x-axis we have the right or the metric IV. Remember, here the ACS is the nominal IV, and the probability graph in form of a line plot has been shown over here. This you will get in R programming. Unfortunately, these plots cannot be yielded in case of the SPSS. I had to run R to show you that how it works. So this will basically add up to this theoretical portion. This you may or may not add, however, for your diagnosis of how your model is working or for any kind of decision making, this graph will be important. APA does not, mandate that this plot has to be shown. Many researchers do not show it. However, this is for your own diagnosis and for your own lookup. So you see, first one is the academic group. I know it is a little bit small. Wait, I'm just making it full screen. Now you can see it is academic. So academic is the first type. The red one is high. The middle one is the blue one is middle, and the green one is low. Okay. So here you can clearly see that the probability, the likelihood probability is showing high in case of the red one. If you take academic, and here if you check which one is higher, the most highest level falls the red one. That is, red is what? High. So the high economics status has a high probability of staying in the academic with respect to right. This probability is belonging to what very variable. This is related to my main DV. Sorry, I mean the main IV, that is the metric IV or the right one. So with respect to right, the high ACS level will score highest on the academic. Okay. And then you can see that in the middle the blue one is there, and on the low run the green is going on. So if I ask you to make a decision regarding, if you, on the basis of writing, if I ask you to choose that in the academic classroom, which is the most surplus or the highest probability ACS group lying in the academic classroom, you say I am most likely to choose a high ACS percent from the academic group with respect to writing both. And which is the least one? The green one or the low one? You note the gap here in between. Note the gap. The red one which is flowing much below the blue and the green is lying, which means there is very high chance, the chance of the probability of a high ACS falling in the academic domain will quite well surpass the low and the middle one. The low and the middle probability of being chosen is more or less similar here. Let us go to the next one. An interesting trend you can find. In the general type here, the probability is high for the green one. However, the decreasing trend is going on. In the academic, there was an increasing trend. The probability along with the writing scores. I mean, the more I go on the x-axis, the writing score or the exam score will increase. So, with increasing the exam score, there will be increase in the high socioeconomic status people in the academic. However, in case of the G, the green is on the topmost level. However, it will be the highest at around 45. You check when the writing score is approaching 45 at that level, the low economic status is basically hitting a peak mark. After that, it is going down. After that, it will just go down. However, they are still surpassing the entire trend, the entire line graph of the red and the blue. Red being on the lowest side, that means when it is the general program, the high people are not much interested. So it is always the low people who are interested in this program, and average trend is seen for the middle one. Let's come to number 3, how you can make an important decision from the vocation program. As there is increase in the writing score, the all of the classes just decreases. So you see vocation programs may seem to be like on vogue. I mean, I'm not generalizing on the real world out there. According to the data, I'm staying within this data. If anybody says that vocation here is gonna be a big hit, then the trend is going down. The more number of writing score you find, the lesser and lesser people you'll be finding here. First of all, here in the vocation group, the scores are gonna lay on the lower side. Whatever ACS the student's background may be, their scores will be lower on the writing exam in the vocation group. Okay. However, the highest one will be for the blue, that is the middle class. The middle class is more suiting here in the writing group. Okay. And the least is the red group. However, again, I'm saying all the three are showing a decreasing trend. I mean, no matter what the ACS is, in the long run, they will score very low. They will score very low mostly. Major people will, the probability will just slow down as the writing score increases. So this is how you make a decision out of it. Okay. So now if I ask you that which ACS do you see that they are, I mean, having a high probability of staying, enduring, adapting to all the three groups? You can see which one is more or less higher. No clear-cut decision is being made. Dekho here, red is on the high on the first one. Red is on the lowest on the second one. Third may be red is on the lowest level. So they are not adapting to all the three equivalently. Green also first may least. In the second one, it is the highest. In third one, it is in the middle. Okay. The blue one, firstly middle, then high. More or less the middle class, then I can say, as compared to the green and the red one. The blue one is more or less holding their position. Middle, high. So it is on the higher side. It is never low, you see. So the middle class people are gonna be adapting to all of the three most likely. Which one is the least likelihood of adapting to all of the three? It is gonna be the red one because high, low, low. And also if you check green, then low, high, middle. We cannot say much about green. However, the least one to be adapted to all of the three overall, which one is the least adaptive? That is the high status people. So here maybe they have no interest in any of the writing programs. any of the academic general and vocation program out there. This is how you interpret the plot. This is how you interpret the visualization, and along with the p values you have to understand which one is significant, which one is not significant, and then accordingly make a decision out of it. So this is how you interpret, this is how you work with the multinomial logit. So that's it. Up to you, sir, now.
Thank you, Dr. Das. You have covered both the theories, computation, and data visualization of multinomial logistic regression. I think students have understood. If they have any question, they can raise the question. Rofur, any question? No, I think everybody has understood.
Sir,
Yes, Amit.
this multivariate statistics which we are going through is mainly related to questionnaires, sir?
Not necessary. Any other data also. Not necessary questionnaire. You can take other data also. Maybe your medical data can be applicable in case of the multivariate.
So I will attempt to answer this question. Multivariate means you have multiple variables going on. Now the source can be any kind of question, it can be any kind of qualitative variable also. Okay, so whatever be the case, if you have more than two variables going on, we call it the multivariate approach. Okay, so the source can be anywhere. It can come from any kind of questionnaire. It can come from any kind of secondary kind of data that you take from the internet. So multivariate data means where the multiple variables provision is there. Where is the source? It is the any kind of data from the internet, or is it coming from interview, or is it coming from this questionnaire? Does not matter. Multiple variable yields multivariate model. Two variable means bivariate model, and this is how you work with. Okay.
Okay.
If any kind of qualitative research is going on, suppose the anxiety and the age, I'm not doing any kind of quantitative also, so it will be a bivariate qualitative research because I am using two variables, that is the age and the anxiety. Generally we don't mention the univariate, bivariate, multivariate in case of the qualitative research. Most of the times it is reserved for this kind of quantitative approach only. Okay, you can learn very well what is uh, singular univariate data. Okay, multiple univariate, one bivariate, multiple bivariate, and one multivariate versus multiple multivariate. You can understand the differences between these things. Read any kind of statistics books. This will help you, understand these things better. Okay.
Now, actually, sir, I am doing a project on body donation, whole body donation.
Hmm.
So,
Okay.
in whole body donation, uh, I am doing a qualitative research where I guess the individual perspectives of the registered donors, means who have registered ourselves, have given a affidavit that they will donate their body after their death.
Hmm.
So there is some data which is present in the literature review that the reasons are like condition to medical science, their body ailments, or after death against their body, so that will help in medical science. So
Okay.
like this.
Okay. If
So
you
can
have
we apply principle analysis, confirmatory analysis, or logistic regression in this type of studies?
Yes, you can, but for that metric data, I mean numeric data should be availed. If it is not, if you are working only with this qualitative data, how can you run the PCA or the factor analysis or the CFA. For that, if you have secondary data, or if you go to collect the primary data from the field, and then you can reduce the dimensions by using PCA factor analysis, always welcome. In this case, you have an interesting topic, and my advice would be that it will be better. Now up to you. I'm not forcing anything, just advising. You can go for the mixed approach. I mean the quantitative qualitative blend that would bring out the true
Yes,
character.
yes, I am doing that only, sir.
Okay.
Means quantitative component is there and the quantitative component is in the form of questionnaire.
Okay. Then so you can, if you have multiple variables going on, multiple elements in your hand, which you believe that you need to shorten it up, which you need to, reduce the dimensions of, obviously run a PC out of it, if the assumptions are made, of course. Sir, am I
But
right?
sir, like if there is already the data is present in the form of qualitative, form of qualitative also and quantitative also. But no one has the PCA, CFA or logistic in this. I find very scanty research.
Then if the data is
So in
working
my
good,
area, if I am doing
yes, I was saying that if the data is
then
working
sir,
good, if the assumptions are being made, you can basically feed to this research gap, and you can fill the research gap by going a novel way. You can do it. Obviously, that will draw more attention. That will be a novel endeavor in your work. You can think about it. Obviously, talk to your guide regarding that.
I am doing this, so I am taking my project. After collection of data, can I approach you, sir, for this?
Yes. Obviously, you can approach me. First of all, approach Sir Dr. Rai sir. Sir will basically guide you. If sir needs me to give you some advice, then obviously I'll be there. You can talk to sir on the first hand level. Okay, no issues. Okay, anybody else with any other question? Okay, sir, I think they are
Yeah,
done.
now we can close it because next class is waiting.
Okay.
The students are joining now. Okay.
All right.
So thank you, Dr. Das, for giving your
Thank you, sir.
Okay, thank you so much. I hope you have noted my email ID. If you need any kind of doubt clearance, you can mail me over there. I can be found in ResearchGate as well. Just type in my name, Ivan Das, and you can get it. Okay. So, bye. Thank you so much. Thank you, sir, and thank you all the students for being here and lending me your patient ears. Thank you so much.
Thank you, sir. Thank you so much.
Welcome.
Thank you.
Welcome.
Hello, Favida madam, you have joined late.